What you see is a 3D model showcasing a terrain and geologic hazard investigation for the placement of 46 wind turbines along the east-west trending Bear River Ridge and Monument Ridge tops, situated southwest of the towns Rio Dell and Scotia in Humboldt County, California. We utilized a variety of datasets, including grading plans for roads and pad sites, a 0.5 meter resolution LiDAR survey collected specifically for the project, covering an area of approximately 28 square miles, regional elevation models, published geologic and landslide maps, geologic cross-sections, previously mapped fault locations, and rock strength data from peer-reviewed sources. Our initial interpretation of the LiDAR dataset reveals numerous landslides and landslide clusters along Bear River Ridge, where soft terrain dominates that is underlain by Franciscan Formation rocks. Although the ridge crest is broadly planar, offering apparent room for development, our detailed mapping and interpretation of LiDAR data shows ridgetop failure features that are known as Sackungen in geologic terms. These slow, gravity-driven ridgetop spreads form linear fissures and uphill-facing scarps that can penetrate deep into the rock mass, effectively decoupling a block from the main ridge. Such features may be linked to prehistoric seismic events and could pose ground rupture hazards under future loading. A geologic fault line mapped along the Bear River ridgetop indicates these linear features were recognized previously and may also be a trigger mechanism for larger landslides along the ridge slopes. As we move on to the easterly laying Monument Ridge, we encounter a much narrower crest and sharper topography, underlain by a unit of the Franciscan Formation that is much stronger and intact. Here, smaller landslides and almost no landslide clustering occurs, and no ridgetop failure features were mapped or are evident in the LiDAR data. Well-incised drainages and steep slopes attest to a more stable terrain compared to Bear River Ridge. Rock quality information and map correlations confirm that Bear River Ridge's highly folded and sheared Franciscan Formation rock types yields rounded ridgelines, whereas Monument Ridge's competent sandstones produce much sharper and stable ridge crests. Overlaying a terrain ruggedness index map vividly highlights this contrast. Red hues mark Monument Ridge's rugged and resistant bedrock, while blue tones denote the softer and deformable terrain on Bear River Ridge. To translate these observations into actionable insights, we generated detailed geologic cross-sections at each proposed turbine location. These sections illustrate existing landslide geometries, ridgetop failure spreads, and subsurface lithologic contacts. Each cross-section integrates our LiDAR-derived landslide interpretation, surface fault traces, and interpreted bedrock layering, providing a three-dimensional picture of where instability concentrates. This qualitative hazard potential assessment was compiled into a submission package for the client and their engineering team, completed with hazard zoning maps, cross-section figures, and narrative interpretations. Our investigation demonstrates clear differences in terrain stability between the two ridgetops. Bear River Ridge requires careful mitigation of ridgetop failure-related spreading and potential deep-seated landsliding, while Monument Ridge presents fewer geologic hazards. Armed with these findings, engineers and developers can make informed decisions about foundation design, drainage control, and necessary ground improvement measures to safely proceed with turbine installation.